Hello everyone, I'm Mugdha. On behalf of DDAG, I welcome you all to the chat show, Silkyara Tunnel, Geo-engineering of an iconic rescue. Most of you must have heard, read and watched the news about this incident that took place in Silkyara Tunnel on November 12, 2023, around 5:30 in the morning. Due to the collapse of a section of the under construction tunnel, 41 workers were trapped for 17 days. Massive rescue operation was conducted to save the trapped workers, and fortunately, all of them were rescued without any loss of life. Today, we'll be discussing about this incident in more detail with our panel of experts. We have today with us Mr. Vinod Kumar, formerly Executive Director, Konkan Railway. He is a tunneling engineer and advisor, having 50 years of experience in hydro and railroad tunnels. Then we have with us Mr. Sumit Jain, Project Director at Rishikesh Karnaprayag New Rail Line Project of RVNL. He has an experience of several years in development and planning of projects from feasibility stage to execution stage. Dr. Dinesh Sati, freelance geology and geotechnical expert. He has spent several years at various academic, research and training institutes in the country, including the Wadia Institute of Himalayan Geology. Mr. Amitabh Sharan, he has an experience of over 26 years in management of tunneling, hydro and infrastructure projects. He has an authority in geological and geotechnical assessment in underground works, including construction of tunnels, shafts, caverns, and usage of modern equipment and implementation of new estuarine tunneling method, that is NATM. Then we have our very own Dr. Gopal Dhawan, founder and chairman of DDAG Private Limited. He is formerly CMD MECL, and before joining MECL, he has served NHPC as Executive Director, Geotech. Lastly, we have with us veteran engineering geologist, Mr. Yogendra Deva, a voluntarily retired formerly Director, Geological Survey of India. He is a consulting engineering geologist for over 42 years. Mr. Deva will be steering this chat show and interacting with the experts today. I welcome all the experts present here today and request Mr. Yogendra Deva to take over and lead the show. Thank you.
Thank you, Mugdha. Thank you very much. I don't have much to say. You have introduced the incidents already, and I will now directly go to Dr. Gopal Dhawan, who I fully understand was involved right from day one with the happenings there, what all was going on, and he was very active on the chat groups and discussing what all has been done, what all is being done, and what all should be done. So I think he's the right person here to introduce the project, the incidents, the ordeal of the 41 entrapped workers there, and other related things. I think he knows what exactly needs to be shared with our audience here. So Dr. Dhawan, please.
Thank you very much, Deva Sahab, for asking me to initiate the discussions. Char Dham Mahamarg Pariyojana is a very ambitious project of Government of India, Ministry of Road and Transport and Highway. Here they are constructing a 900-kilometer all-weather road project, which will connect our 4 holy towns in Uttarakhand, namely Yamunotri, Gangotri, Badrinath, and Kedarnath. This tunnel, Silkyara, is towards the Yamunotri side, between Yamunotri and Dharasu. After completion, this tunnel will, this is the portal of the tunnel, Silkyara portal, as we call. This is a 4.5 kilometer long highway tunnel. It's a semicircular tunnel with 12.4 meter base and 7.5 meter height. The one portion of this tunnel got collapsed in between chainage 205 and 260. These are the initial pictures of the collapse. almost a day after that this was the picture. You can see that debris is seen at the face, and a lot of lattice girder in broken shape are also visible. Immediately after, NHIDCL through Messrs. Navyuga Construction Company, who are the contractors of this tunnel, they started rescue operation and they started removing the muck. However, as all of us know who are associated with tunneling operations, that it really doesn't work, because the more they removed, the more it came. So you can see in this picture that the original mass of debris is now increased. Somehow there was a 4 inches diameter pipe, original pipe, through which it was the lifeline for workers, and it continued. I mean, the authorities continued to support the trapped miners through this, and the news was that they are safe and some basic necessities are being given to them. Through this, I will just take half a minute to explain that in this section you will see that the status of the tunnel is that from Silkyara end, about 2,300 meter has been excavated through this pink line. I'll take my cursor here. Yeah. So you will see that this is the excavated portion. From Barkot end, this is the excavated portion, which is about 1,700 meters. This portion is unexcavated, 477 meters, and this is the collapse site. In this block diagram, you will see that this is the collapse. This is the muck of about 60 meter in span. These are our trapped tunnelers. And from this end, rescue operations were going on. And in between, this was the unexcavated portion. So this is the total picture of the situation when the collapse occurred. And rescue operations continued through several means, which my colleagues, my co-panelists will explain further. But in nutshell, once they realized that this removal of muck will not succeed, an old machine was, auger machine was deployed from Uttarakhand irrigation, but it also broke down very soon. And then an American auger machine was brought in, but that also broke down. But parallelly, NHDCIL, they continued to construct a second lifeline, and through that 9th day, a 6 inches dia pipe could be inserted, and communication could be established with the workers, and finally some solid food was given, and an endoscopic camera was also installed there. So this is all. I think I will come back in the second round if you want more information from me. Thank you.
Thank you, Dhawan Saab. Thank you very much. That was a very good introduction to the tunnel. Having done that, now I think it is time that we had a look into the ground conditions of the tunnel. I mean, where such a collapse took place. So I think let us just start with the initial work, and in that project area where the initial engineering geological assessment was made. And we have with us Dr. Sati, Dinesh Sati. He has done some good, wonderful job there. And we believe that his projections have proved right. And I will now request him to please brief us exactly what exactly was the geological assessment and what did it indicate there. And if he gave some recommendations about what all should be done for a smooth tunneling for this project, so he should share that also with us. Dr. Sati, please.
Thank you, Dhawan. I was involved in the project in the initial phase where the tunnel alignment was fixed by me only, and the preliminary feasibility investigation were done in 2012, April-March month. Because there is no access to the tunnel alignment, immediate access. So geological information which was available on the outcrops along the highway were projected on the tunnel alignment. To the best of my ability and knowledge, I projected the rock mass parameters and all the geological information on the tunnel alignment. And except for the Silkyara and the Barkot tunnel ends, where I was having the enough, outcrops to know the rock mass and structural parameters. The on the chain is 300 CS 300. There I projected the contact between the amphibolites on the top with the siltstone and fine-grained sandstone, the sequence, and that contact of about 40 meters was suspected as seared, and exactly on that area only the tunnel collapsed, because it was already a seared zone. But I don't know if further investigation were done by the authorities, those are involved in the project execution. But this picture was already there. Drawings which were supplied to the SAVN for excavating from the top, drilling from the top of the tunnel ground. That exactly is passing over the 300-meter chains. Metasiltstone, sandstone, and slates, which often are referred as phyllites, are class 4, class 2 to class 4. They range in strength. But these amphibolite and metavolcanics are very strong rocks, class 1, class 2 rocks. And the zone in between these two formations, two different rock masses, is seared on the outcrops those I have seen along the highway, because the condition under the tunnel, inside the tunnel, should be little bit wet, so the rock mass parameters goes down. And that is why this whole section experienced this cavity and all events along these changes, especially between 200 and 300 meter changes.
I believe you have got some photographs of the rock types, and you have also got the springing level geological plan, which shows this contact and the nature of the contact, the shear mass.
That's right, sir. That's right.
I think this is this is the amphibolite, very competent rock.
Yes, they are very competent. Very competent.
And this photograph, I believe, is from that Silkyara and portal.
Yes, this is a portal and at Silkyara, and the rock class 2. It's very good.
Yeah, looks good. It looks good.
Yes, it's good. Yes. Only the zone between 200 meter and 300. That was the critical zone. Yes.
Can we have a look at the plan, at the springing level plan?
Yes.
Briefing about the shear zone there.
Yes, yes.
Do we have any other plan here? I think
yes.
Yeah, this one.
The bedding orientation is not exactly parallel to the drive direction. There is 27 degree variation. So obliquely it goes, and the zone was not so difficult for the tunneling. Every shear zone has a thin zone of intense shearing, and on both the sides the rock mass gets better. So this zone, the highly sheared zone, should be much less. But yes, of course, the entire band between the 235 and 300 changes. This was considered as class 4 or might go into class 5 also. This one.
Yeah, and as I see here, you are showing
Yes,
the width, the thickness to be about, I mean, the width on the plant to be
Yes.
40 meters, but
Yes, sir.
obviously because of the angle between the strike and the tunnel direction, this width will increase along the tunnel, and that is why
Yes,
we are
yes,
getting
yes.
such a large span failure
Yes.
in the tunnel.
So
maybe.
area of coverage was between 200 and 300 meter changes.
And this
Other area.
location also is coming almost very close to it. So,
Yes.
I mean, do you think that this unavailability of access to the tunnel alignment, I mean, this
Yes.
kind of work, I mean, which we
Yes.
do away from the tunnel alignment, wherever it is available, I mean, it
Yeah.
compensates for that inaccessibility.
Sure, sir. That's true.
Devsab, can I come in?
Dhawan Saab, I'm about to ask you. I mean,
Yeah.
I think you have got a lot of experience in this. You've done very hard work, a number of projects. What do you say about it? I mean, that is the power of engineering geological mapping, as we call.
Exactly. I first of all commend Mr. Sati that at the PFR stage he has created such a good geological map, and his model really got verified during the construction, because this is not only the significance of a shear zone, but also it is understood that there were so many cavities in this particular zone when the tunnel was initially constructed or excavated in 2019. And incidentally, this is the same zone where this collapse has taken place. It means that the geology of this area, the geological model of this area, which was established during PFR, was really very good. And here lies, as you said very rightly, that this is the power of engineering geological map if it is done properly. And secondly, I would like to add that in tunnel, although the protocol of tunnel investigation involves right from topographic survey to geological mapping to geophysics to airborne geophysical surveys, drilling, drifting, and nowadays even in foreign countries directional drilling is also done. But geological mapping remains the most important component, because particularly in Himalayas, where we do not have access to the tunnel alignments, we cannot take our big drill machines there. Only geological mapping will help us in understanding geology, and this is the case where geological mapping without any supplementary investigation of geophysics or drilling, the model was as accurate as it could have been. I mean, I have never seen such a good projection based on the PFR mapping. So full marks to Mr. Sati. Thank you very much.
I
Thanks,
did
Dr.
to your observation. I did to your comment, Dhawan Saab. It's a
Yeah.
remarkable job which has been done in PFR stage. And now, I mean, now I understand that we have Amitabh Charan with us, and he has been associated with the detailed engineering investigations. And I think that he must be having a lot of information after Dr. Sati made the exit from the project after his work. So, Amitabh, can you share with us?
Yeah.
I mean, the data which you have or the experience for this tunnel?
Namaskar, sir. I'm associated with Barnett Engineers from detailed design engineering stage. We are the sub-consultant to Barnett, and we are responsible for the detailed investigation. Also, what we did and how we did. In brief, there are 3 borehole initially planned. One is Silkyara portal, near to Silkyara portal. One is the near to Barkot portal, and one from Barkot side, a low cover zone. The third hole is proposed here. Apart from that, geophysical SRT has been conducted from Silkyara side. we have superimposed that data on this sections. And the second layer of second line of SRT will done from both the drill hole in between. The one another low cover zone. So we have done the SRT here also. Based on that, this is the composite map, and during surface mapping, we have done some homework based on the foliation direction or the bedding direction. We projected at the surface, and that band along the road, my field geologists will capture the joint data, and that entire data we will amalgamated the data and projected in this section. So we try to decipher as much as possible based on this the subsurface drilling, geophysical, as the detailed surface mapping religiously done at the site. So this is the detailed map. Initially, first we have found that 150 RD. There was a 120 to 150 RD. There was a collapse 3 years back from the crown. Or the same place we projected our one shear zone from the first hole near to portal. Okay, sir. And this is the detailed surface geological map of the area. The tunnel alignment is almost the skew between the tunnel alignment and the foliation, the main principal joints is around 20 to 22 degree. And this is the closer view of the section. This is the foliation direction. The lithology is metasill stone, or you may call it the phyllites. It's in transition in between. So this is the one map of granodiorite intrusion. We got that from some Google paper. So we projected this data also. So in our projection, this band has gone below the tunnel alignments. And during construction, most of our section, what we projected till date, it has already matched with the actual construction at site. So in my interpretation, the entire area, entire tunnel alignment is drive through the soft metasill stone, is highly crust. At some location is enriched in muscovite also. Phyllitic, sometimes it's look like a phyllitic in nature. Accordingly, we already given the details to our designer, the Barnard, Austria. They have designed based on our geological input.
Thank you.
Right.
Thank you, Altaf. I notice one thing here that I can see at the Silkyara and the geophysical survey result.
Yeah.
That I see a low resistive, low velocity zone, which is almost touching the tunnel ground.
Yes.
That end.
Yes.
So, but that rock should be where the low velocity zone is coming. That rock should be the competent amphibolite.
No, sir, unit. It's not amphibolites. In my projection, that amphibolite or that granodiorite, just intrusive, it goes below the tunnel alignment.
Okay.
Because we have done some pit. We have done some pit in regular interval at the tunnel alignment also, sir. Apart from the drilling.
I just wanted to ask one question.
Sir.
Because I'm not able to see exactly where is the contact between the two litho units. You have also identified two litho units or one litho unit?
No, sir. In my section is one litho units. That is hard intrusive goes beyond that tunnel. Okay. Based on our information, based on detail mapping, and I explained earlier So we projected the bedding or the foliation data up to the top surface level, and that strip my geologist has mapped in very detailed manner. So we have more than 2,000 joint data, and based on that, more than 2,000 in one portal, Silkyara site.
Just one question I had.
Yeah.
Do we have any information about the weak zone which led to the collapse? Yeah.
So that is already we have marked RD voice class, and this is already discussed and detailed explained in our GIR. Okay. Even three years back, the collapse has occurred at 120 RD.
Okay.
So that section we have projected that shear zone at that RD.
Okay, thank you, Amitabh. Thank you very much. This is quite a detailed, quite a detailed geological section you have shared with us. Good information.
If you want, we will share the detailed GIR also, sir. Okay. Even every rock type we will do the we have done the petrography also.
Yes.
So that report, all reports are with us.
Okay, I understand that is how the detailed engineering geological investigations are carried out. I mean, no rock is to be left unturned, basically. Anyway, now we proceed further. And before we go to the other technicalities, I will, I think, turn to Sumitji and ask him that what does he think about the design of this tunnel? Because I am representing the audience here. I will say I'm a layman. I understand probably that all the tunnels like this, transport tunnels, they have got an egress. And egress is normally a parallel tunnel which goes along the tunnel alignment, basically. So had an egress been there for this project, maybe this rescue operation could have been easier. So from that angle, I would just like to learn from him that what does he think about the design of this particular tunnel, where at least I don't see any egress. Sumitji, please.
Coming to regulations for safety in transportation tunnels specifically, there is a particular requirement that the safety or the escape path for the tunnel users, be it during construction or be it during operation of the traffic tunnel, that should be totally separate and isolated from the main tunnel that is being constructed. Now, we can take the adjoining tunnel as a safe or escape as a safe escape path, or else if the same tunnel cross section is providing a safe area for this escape, then this should be available for rescue of persons under all possible events. Like for example, in case of Atal tunnel, the safety path is just below the carriageway of the road. So that strategy is perfect when it comes to regulations for safety in transportation tunnels. So in no case the tunnel should not be available for rescue. That is the prime concern and the main strategy for designing the project. Coming to Indian Railways, a separate escape tunnel is already mandated by the Railway Board, and all our railway tunnels are having an escape tunnel parallel to the main tunnel, which is a non-traffic tunnel. And for all tunnels more than 3 kilometers long, we are providing such provisions. Internationally, if we see the regulations for safety in the traffic tunnels, the safe area should be present every 500 meters along the traffic tunnel. Now, the safe area can be an escape tunnel connection, or it can be a cavern, or it can be an edit, or it can be a shaft or a ramp where people can escape, self-rescue, escape, and be safe till somebody comes to rescue them. Now, in case of Silkyara, as everybody knows, a central wall has been provided to isolate the safety path. So in case, because this central wall, what it is doing in that tunnel is, it is giving a bi-directional, it is separating the direction of traffic. So if the emergency happens in one direction, now there are doors in that central wall. That is what I heard. So people can escape to the other, in the other area of the tunnel. isolated by this vertical wall. Now, in my opinion, this design or this strategy should be revisited after this incidents, because if there is a severe accident during the later operation stage, then there can be a case where vehicle can dash with this central wall and it can destabilize the entire tunnel structure of both carriageways. So this is what I wanted to say on the regulations.
Thank you, Subhuji. I mean, this is very interesting and quite illuminating. And having, introduced ourselves to the ground conditions about the design and all other things, now I think is the time to come to the main rescue operation, the technicalities of that. And for that, we have a very experienced tunnel engineer, Vinod Kumar is there. I will request him to kindly enlighten us on what exactly was done there and how exactly it could have been done in a better way, whether it was possible.
This is the long shot of the tunnel where rescue operations were going on. So this is the old auger machine which was pressed into service first. And as per the newspaper report, this was this belongs to Uttarakhand Irrigation Department. So it also was tried and it worked for some time. It went a couple of meters ahead, but finally broke down. And here, what happened with this machine was that although you see the function of the auger machine is, you will see that we have the spiral blades. So as it cuts the debris mass, spirally it brings out the material, and then a circular space, hollow space is created. The idea was to insert the 900 mm pipes by jacking. So this was the original machine, and then when it did not work, then this American auger machine was brought in, which is the blue color you can see, and the pipe is inserted through this. So this machine also broke down after going about 25 meters or so. And so there was a state of panic when it happened. Everybody thought that now everything is finished. So at that stage, the leaders who were leading the rescue operation there from various departments. One good thing about this rescue operation is that the whole of the country, they joined hands together. Can you imagine that there were more than 12 government organizations, all very competent and specialized organizations who were there, namely NDRF, SDRF, NHIDCL, Geological Survey of India, our own department, ONGC, SJVNL, Rail Vikas Nigam Limited, RVNL, RITES, Border Road Organization, Indian Army was there. Coal India was there because they have a lot of experience in handling mine collapses, and particularly in Mahabir Quarry, there was a collapse and they rescued everybody through a vertical hole. And then Simfer was there and Uttarakhand departments were there. There were, all the good private companies tried to join the rescue operation, and many of them did it voluntarily. Like, our friend, Dr. Sanjay Rana, he sent his geophysical team from Parson overseas, which he owns, and they did a wonderful job to support the rescue teams so that, they can look ahead that what lies ahead of this auger drill route. As it happens in all the geophysical techniques, there are limitations, and finally at the end, perhaps some interpretation went wrong, and the machine finally. So then, I was telling that this incident happened twice. Once thrice. Once the old machine broke down, Then the American auger was brought down. It went for about 24-25 meters. Then the machine broke down, and the pedestal on which it was mounted, that also broke down. And there was a panic that perhaps the tunnel is getting unstable, and therefore now we will have to stop rescue operations through auger machine. At that point of time, everybody joined hands together, and they started working on all the possible fronts which could be possible, because now the time was running out, and already I think 9 or 10 days were passed. So at that time, a vertical hole was planned, which Mr. Sati has shown in his section, and Mr. Vinod Kumar will also show. So that was the second alternative. The third alternative was to make a drift. It was the original idea of Mr. Vinod Kumar, who is one of our co-panelists, and he will, I'm sure he will explain that what was his idea. The fourth alternative was to drill from the opposite end, which was 477 meters. It was a huge Herculean task. But in case, nothing works, because after 2 or 3 incidences of breaking down of auger machine, the confidence was shaken. And then work perhaps on all the fronts started. And one day before the breakthrough, on 28th November, the news came that about 44 meters of the vertical drill has also been completed. So we were very close. Almost half the drilling was completed through a 1.2 meter diameter hole. And the SIMFO team and the Coal India team was there with a pre-designed capsule, that in case the rescue is done through the vertical hole, so how the people will be evacuated. And but luckily, the last mile was achieved by the rat miners. The miners who are prohibited, the miners who are illegal. And the rat mining is an illegal activity as per our rules. But they came to the rescue, and this American auger broke down at 55 meter or 56 meter. Still about 15 meters was to go, and that was hand chipped by these young brave boys who were 12 in numbers. They belonged to a private company in Delhi, and most of them belong to areas around Bulandshahr or Greater Noida, and they did a wonderful job.
I have heard Dr. Sati, Mr. Jain, everybody, very nice. But then point is to save the people in minimum time. That was the objective of above all, everything. And arrangement of putting pipes in the hole or vertical drilling, everything is it. For mobilization of every activity, it is time consuming. So my idea, as I gave in this sketch, was a small drift at the top. And Dr. Dhawan, the people who made this drift, they are simple workers. You can call them rat miners, because to construct a 1 meter by 1 meter drift, it is not simple thing. You have to go crawling in the area. It is a very limited area. Why 1 meter by 1 meter? Because excavation quantity should be less, and you should have more linear progress. That was the idea. So anyway, now job is done. My point is, for future, this type of program should be given to the disaster management people, that in any project, if such type of eventuality takes place, no mud removal whatsoever may be. They should try to approach the access through the fallen mud by creating some passage. Now passage can be through these small drifts or through the pipes, as they did it. Now pipe pushing, again, this machine is not regularly used in any of the tunnel projects or any of the sites. You have to, it is a bought-out item, or you have to arrange it. Like micro tunneling, you have to order it. So anyway, here it was ordered first. They arranged a machine from Uttarakhand government, then second machine they got from somewhere else. And one thing is for sure. You see, the machine broke down not because of the machine was faulty. It broke down because it came in contact with algae. Those rattled algae which were lying below the buried mud, it was broken due to that fact. I had one gentleman, Mr. Harpal Singh, who was supervising this work, who was also involved at this site. He was giving me feedback that when they were trying to reach after 45 meters, he suggested that there is a jumble of algae in front of the pipe, and they will not be able to break these pipes with the auger. In that case, they contacted the owner of the machine. He said, no, my auger is a very strong auger. It can cut anything. And they again put the auger inside the pipe, and it got spoiled. Ultimately, it had to be cut and taken it out one by one. So that was that activity delayed the progress. At the 45 meter initially itself, when they had reached and they had encountered the steel in front of the pipe, they should have simply stopped the activities, put the rat miners or whatever welders, gas cutters inside the pipe, cut those things and remove one by one. So probably they could have saved 4 or 5 days in this process. The escape tunnel, Mr. Dhawan has spoken Mr. Jain has already told you. This is essential in such type of tunnels. It provides second line of defense, as well as the geology much better, much in advance. So, this type of things, vertical hole drilling, again, Dr. Dhawan, it takes time to mobilize the machine. And then, the whole geology you have not surveyed properly. Now, what I see from the pictures, it was a 1 feet drill hole initially done. Now, had they done another 45 meter hole also, afterwards also they had to ream it. And my experience is reaming the hole, reaming these race climbers as they race borers they do at the sides. They put a bigger side bit below the rod, and then they go on lifting and it keeps enlarging the hole. So that drilling was also not easy option. What they have done is best. Pipe pushing was the best at the time, but steel cannot be cut by others. It has to be cut by putting gas cutters or the other options. So that's all I would like to add.
Thank you, sir. Thank you. I just have one more question in my mind.
Yeah.
At what stage the decision on rat miners was taken?
Auger was broken and you had a steel in front of the pipe.
Yeah.
There was no option but to put miners inside that. And those rat miners were not only the workmen who removed the debris from the pipe, but there were gas cutters also who cut the
Whose idea was this? Whose idea was this? Whose idea was this? Whose idea was this?
There was one person, Harpal Singh. He is from, he used to work at Chamera 1. Then he worked at Nagpur. Now he is in charge of this Jojila tunnel for MEIL. So it may be his idea, but then he used to tell me every day, sir, we meet, discuss.
Okay.
Mr. Deva, I would like to come in for a minute.
Yeah.
Can I?
Sure, sir.
Yeah. Actually, Mr. Vinod Kumar could not show you his slide because he is speaking from Abu Dhabi at present, and he is in transit. So this is the sketch which he shared with me third or fourth day of the incidents. He was very clear from very beginning that a drift should be created at the top. I will show you with the laser pointer. This is the collapsed bark, which this sketch is developed by him, and this is the ramp. Through ramp, he says we could have gone up, and then this was the minimum thickness of the mud near the ground. And the second advantage was that there was a lot of lattice girder which were buried under the muck, and a lot of equipment was also there. So it was expected that almost at the top such problems may not be there. So but the only thing was, because he was in Abu Dhabi, we were here, we shared these ideas on LinkedIn with many people. He also shared with Mr. Harpal Singh. But in the meanwhile, this auger drill has almost reached to the almost its end. So you asked that at what was the stage when this idea of red miners was decided. I heard from Mr. Vinod Kumar at that time. He was of the idea of doing this drift by putting somebody like red miners in our hydropower projects. We have trained teams for doing investigation teams. So, but at 55 meter, when the auger machine broke down, the spiral bits were broken down inside the pipe. So there was no other option but to press rat miners into service. So that was the time. And you know how much time they have taken? Hardly 27 hours. In 27 hours, this team of 12 boys, they completely removed that hurdle of 15 meters, and the other end was seen. And by clearing the muck, they went on the other side, and then they met the trap tunnelers or our workers, and everybody was evacuated. So just to be I mean, I wanted to highlight contribution of Vinod Kumar ji.
Thank you.
I will.
Thank you
1
very
minute
much.
I will take Dr. Dhawan, please. Just 1 minute. Just keep this sketch here. You know, this is what, when I shared my handmade sketch first, second day of the incident, and I was shouting. Actually, I was frantically trying to that I must tell somebody at site that they should not remove the muck. But you know, this every time at every project it happens. They just come inside, the people are there, remove the muck, and they make the situation grave. And that's what happened exactly on this project. You see, had them not removed any muck, and instead of muck, removing the debris, they should have brought some good rocky material from outside and made a ramp like this and tried to reach this point. This would have been done in 8 to 10 hours, and drift length would have been hardly 30 meters. Sir, your rat miners were required at this stage. They would have just done the job in 2 days.
This is the drift.
And I sent a message to Arnold Dix also, because we had met last April at Pune. I thought he may recognize, but thing is, there were so many agencies involved and so much pressure from the media, government, even PMO, that things should be done the way it came on the way. That's all, sir.
Thank you, sir. Thank you very much. I think now it is time. We have taken a lot of time here for the discussion. Yeah. Now it is time to conclude. So I will just ask one question, and I will ask it from Sumitji. That I mean, he's sort of a project owner. He's making tunnels, and in an emergency like at Silkyara, what should be the approach of the project owner? In this case, NHIDCL was there. What should be the approach? That who all should be consulted as an immediate decision on what exactly is to be done? Engaging, I mean, is engaging foreign experts a must in such situations? Because we have this particular incident has shown that the Indian team has done it, and I mean, it's a remarkable rescue operation they have carried out. So, as a project owner, what do you think should be done in such situations, Sumitji?
Sir, as a project owner, I think that firstly, if I was there, if our company was there in that scenario, firstly we would have collected all the data that we had recorded while the first stage of tunneling was happening for 3 years back, 4 years back. And we would have also collected the convergence data for the next 2 or 3 years. We would have analyzed what is going on behind that stretch before even touching that or reprofiling that stretch. So that was the first strategy that would have been in place had we had our company been there. And then secondly, coming to the event that happened, if we were there, we would have shared that data transparently with the best experts that we were aware of, be it Indian or international, it does not matter. We would have consulted, or we would have shared that data across the website and invited comments from all around the world. And then we would have, in the Indian circumstance, whatever the best machines were available nearby to the project site, because time is of prime importance to rescue at the earliest. So looking at that time, looking at the solutions that would have come in front of us, and looking at all the possibility of nearby machines, we would have adopted a best approach in that case.
Sumit, thank you very much. I think you have put it very nicely, that what exactly could have been done. Actually, in such situations, I also feel that it is the brainstorming which is needed immediately, because
Yes,
as in medical they call it the golden hour. So I mean, you have to act fast. You have to take take everybody on board, whosoever you think are experts, internationally or nationally, it doesn't matter, and take a decision on that. So I think now we come to the end of it. We had planned to conclude this session in 30 minutes. We have taken about, I think, about 50 minutes. But these things happen in such discussions. We get carried away with our own findings and our own views. So now I think I will not thank you. I will leave that to Mugdha, who is waiting here to. She welcomed you, and now she will thank you. Thank you, Mugdha. Thank you for everything.
So before going towards the thanking all the experts, if you permit me, I'll take just a minute and raise one query. It is addressed towards Mr. Jain as well as Mr. Sharan. Something just came to my mind that because we already know that this 100-meter zone is kind of a weak zone. It has already been, it has troubled the tunnelers in the past also. Going forward, what do you think will be the stability of this tunnel? They'll treat it again, whenever it comes into the operation. Are they looking for a possibility of an alternative route for this tunnel, or whether such alternative was considered in the planning stage? Probably Dr. Sati can also add a bit because he was there in the feasibility stage. Whether any such alternative studies were carried out? Is there a possibility to change the route now? I mean, this is particularly addressed to the to Mr. Jain, being the construction man.
yeah. Coming to the way forward, how can we now take the things ahead and construct the tunnel and finish the project and hand it over to the country? I think that firstly we should conduct aerial geophysical survey to capture the extent of the cavity which is there, because that cavity cannot be investigated through any destructive investigation methods. So firstly, there should be a non-destructive way to find out the extent of cavity, which nobody knows right now. Then we should devise a strategy to conceal that cavity, and then we should monitor it for a certain more time period before commissioning the project. And even while during final lining of that stretch, we should install pressure cells and strain gauges in the rebar of that area of final lining, and we should continuously assess the performance of the final lining structure in that stretch. So that can only give the confidence, and in case anything future again something wrong happens, then this data will help to evaluate where we went wrong.
So does such monitoring continue even during the when the tunnel is under the operation, like it is open to the public? Will they be doing such like observations? They should ideally. I mean,
They ideally they should, because after such a big tragedy has happened, so we can easily isolate the shear zone where it has intersected the tunnel. And now I think they should not do the final lining without instrumenting that lining and ensuring the stability for coming years.
Yeah, because people should have confidence, while traveling in
Yes.
that particular particular tunnel.
Yes.
I'm just
Yes.
saying because they are going to the Char Dham Yatra is anyway quite
Yes.
difficult. Okay, thank you so much. I sincerely thank all the experts for sharing their knowledge and more importantly, sparing their time, out of their busy schedule.
To your question, Mr. Sharan wants to add something.
Yes, sir, please.
Yeah, just in continuation with Jan sir. So I just want to just add on that. During construction, monitoring is very, very important. So every designer has designed with a certain deformation tolerance. If deformation goes beyond that, it should be give proper additional support immediately. So that monitoring during the construction is religiously implemented in every construction project in regular interval, and that data is not for a just to take the data and keep it in the laptop. It should be given to the expert and the designer to analyze in the real time analysis day-to-day construction stage, so that if anything alarming, because as a geologist, my past experience in NHPC and in the many tunnels, nature give signatures before going any bigger catastrophe. It gives signature in the early times. So it's us to understand that signature and give the proper support immediately, so that in future this type of catastrophe will not come.
Right. Well said, sir. I mean, the collection of the data and handing it over to the right person who can understand it is a very crucial part, basically. Right. Okay. I once again thank all the experts, and I don't think I need to thank Deva sir and Dhawan sir, but on behalf of them, I thank all the experts once again, and it was good to have you all here. Thank you so much. Thank you.
Thank you.
Okay.
Thank you. Thank you, everybody. Namaskar.
Thank you, everybody.
Thank you.